Hey guys, welcome back. So what we're looking at today is 4.5, just act rational. So what we're looking at here is trig functions. So we did this last year. So we want to write the values for sine A, cosine A, so on and so forth. So for sine A, remember we start from the angle. Sine is opposite over hypotenuse. So this would be 12 over 15. Cosine is adjacent over hypotenuse, so 9 over 15. And then tangent is opposite over adjacent, so 12 over 9. Now, from the other angle, sine B, opposite over hypotenuse, we have 9 over 15. Cosine's adjacent over hypotenuse, so 12 over 15. And last but not least, opposite over adjacent will be 9 over 12. All right, so same idea for number 2. For number 3, it's at an angle, but it still works the same. So opposite over hypotenuse. So we have 7 over 7 root 2. Cosine is adjacent over hypotenuse, so still 7 over 7 root 2. Tangent's opposite over adjacent, so 1, because 7 over 7. 7 over 7 or 1. So tangent B will also be the same. Sine B and cosine B, guess what? They're all going to be the same because this is an isosceles triangle, so everything stays the same. In number 4, sine A, so from here, opposite over hypotenuse, so 10 over 26. Cosine, adjacent, 24 over 26. And tangent, opposite, 10 over 24. Sine B, so from this angle, opposite is 24, hypotenuse is still 26. Cosine B, adjacent is 10, hypotenuse is 26, and then tangent B, opposite over adjacent, so 24 over 10. So you only have one left to do here for yourselves. All right, the next section is looking at adding, subtracting, multiplying, and dividing rational functions. Rational is your key word for this lesson, rational. So Angela simplified the following rational expressions. Only one of the 3 problems is correct. Determine which one she answered correctly, then identify Angela's errors in the 2 that are incorrect and correct them. So we have 5 over x minus 3 plus 2 over x minus 1. So she multiplied the first fraction by x minus 1, both top and bottom. So far, so good. Then she multiplied this one both by x minus 3 because we need a common denominator to add. Then she multiplied through, so she multiplied 5x times x to get 5x squared. And then, the error, notice it shouldn't be minus x, it should be minus 5x. So this one is incorrect. Distributed wrong. All right, so let's look at the next one. Here we have x over x plus 3 minus 4 times x plus 3 over x minus 1. So those 2 things are the same. So they canceled them. Then they have x minus 1, or x over 1 minus 4 over x minus 1. Then they multiplied. The thing is, you can't actually do it like this. You can't cancel like that because it's subtraction. So this is incorrect. So that means this last one is the one that she did correctly. So this one is the correct one. All right. The next section, we want to take and simplify the expression. So notice we have common denominators. So 2x plus 6 minus 4. The only thing that's going to change is the 6 and 4. So we'll have 2x over x plus 1. Or sorry, 2x plus 2 over x plus 1. Now, 2x plus 2 and x plus 1. We could take a 2 out of the numerator. So we'd have 2 times x plus 1 over x plus 1. Guess what? We can cancel those, and we're left with just 2. So 2 is our answer. Now, in cases where the denominator is not the same, we have to make it the same. So we are going to multiply this one by x minus 5. Sorry about that. And this one by x plus 2. So this becomes 2x squared minus 10x plus x squared plus 2x minus x minus 2 all over x plus 2 x minus 5. Combine like terms. 2x squared plus x squared is going to give us, hang on, I think we're spaced right, is going to give us a 3x squared. 10x plus 2x is, or negative 10x plus 2x is negative 8x minus 1x will give us a negative 9x, and then minus 2 all over x minus 5 x plus 2. So this right here is our answer. We can't simplify that any further. So same idea for these. Now on the ones where you're multiplying, those you can cancel. Same with the division. And remember, same times flip on the division ones. Okay? All right, comparing rational numbers and rational expressions. So whole numbers are rational numbers with a denominator of 1. Rational expression, polynomials are rational expressions with denominator 1. For B, rational expressions are undefined when the denominator is equal to 0. For rational numbers, numbers of the form A over B, undefined when B equals 0. Next one, when you add, subtract, multiply, or divide two rational numbers, the result is also a rational number. So for rational expressions, same thing. When you add, subtract, multiply, or divide rational expressions, so add, subtract, multiply, divide, the result is a rational expression. And the last one, rational fractions are classified as proper fractions when the numeric value of the numerator is smaller than the denominator. For rational expressions are classified as proper when the degree of the numerator is smaller than the degree of the denominator. So degree of num smaller than degree of denominator. All right, and the last section. So identify the values of x for which the expression is undefined, if any. So we're trying to find out what makes the denominator 0. So this first one, what plus or what minus 4 is 0? Well, 4. In the last one, it's just 5. So this is none. It's always going to be defined. What plus 15 is 0? Well, negative 15. So you have one left to complete there. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.